just a few things, some of the things that we have touched on. So the first thing is we're going to talk about the different protocol, right? The different messaging format. So the first one that we're going to take a look is the TCP, which is not something new, right? Transmission Control Protocol, right? So this layer, as we explained earlier in the OSI layer, is basically take care of the reliability of the transporting of messages, right? To ensure that the message you transfer is correct and is proper and order, right? So if in the event there's some problem, it will basically be able to ask you to resend, right? So it creates basically also the connection between the sender and the receiver, right? So the other important thing to take note is the port number, right? Some of you might notice that actually other than IP address, right? So far I've been looking at IP address, right? Version 4. There's also a port number, okay? After a semicolon like this, right? There's also a port number. What exactly is this port number? This port number are very important because it serves as a way to identify which message this program is for, which program, which application, right? Is it for Microsoft Office? Is it for Microsoft Outlook? Is it for IE Explorer, etc.? So it depends, right? So there is this port number to identify, right? So for example, there are certain reserved port number like port 21. So it basically for file transfer protocol, right? File transfer, or for Telnet, or when you're serving the internet browser application, it will be port 80, right? And of course, if it's a secure connections, is 443, right? So there are certain popular port number that people use, right? These are important. Like I say, the message is delivered right to your doorstep, but then this message, this letter is for who in the family members who stay in that address, right? So the same goes to an IP address. It only send right to the computer, the workstation, but then the workstation itself got so many other applications running. So you also got to narrow down which application is the message for. So that's the reason for this port number, right? So so you can have the same address but different port number, right? Like look at this. This is the same IP address, right? Same IP address but different application, messaging for different application. Right? So so you also can have a port 80, just like I mentioned. Port 80 are usually for HTTP requests, more for browser-based requests, right? When you surf the internet using a browser, HTTP, hypertext markup, right? Or no, hypertext transport protocol, right? So so you can see that this message is sent across to this IP address over here, right? But inside this server, okay, in this case is a server, okay, it has got a few services running, right, which is the FTP, port 21 or port 80 and a few others port, right? So you can also write your own program and then you designate your own port number, right? You can fix your own port number, provided it's not used by the popular one, the reserved port number. So in short, the port number also help to identify the services that is meant for. Right. So TCP basically makes sure that your end-to-end transmission is error-free, right? There's no error. It ensures the reliability as well as the integrity, right? The integrity of the message. So they uses the checksum. Okay, so checksum is derived from some hash algorithm, right? So that it can generate a kind of a summary or some kind of checksum, so they can verify whether anyone has altered the information or the information has been corrupted, okay, during the transportations, right? So you need a checksum basically verify, is there any changes or error since the person from the sender side, okay, to the receiver side. So they usually do generate another checksum to verify with the checksum that is being sent. Then in TCP, you also find that in part of the TCP header information, it also contains the priority bits, right? So that basically defines the urgency of the message, right? So like some business traveler, they get to check in earlier, right? They get to get into the plane faster. So there's some priority that's given. So for messaging itself, there is also a TCP protocol that defines the priority bit, the urgency of the messages, right? So where is this? This is over here, right? So you can see that this is a message header for TCP, right? So they are all embedded by the various TCP header, right? These are the few that has actually been defined, and not just the source port number, but also the destination port number, right? So this is just now what I mentioned. The port number is the one that define basically the services that you want to send to, right? And of course, the sequence number will be the packet size, which are you number one, number two, packet number 1, 2, 3, 4. That is the sequence number, right? And also the checksum that define the integrity, right, of the data, right? So you will also send over the checksum, right? After you send over the checksum will also be generated, okay, by the receiver, so that it can verify against this checksum. If the checksum received as well as is different from the generated checksum by the receiver, then there's some problem with the data. And also a 16-bit that contain the urgency, whether it's high priority, high urgency, not so urgent, etc. So they based on these pointers, right? So you can see there are a quite range of these are the header field, which is actually scrutinized by the TCP protocol layer, right? And of course, what behind, we call this the header because it's embedded in front of the message, the data, right? So these are just a small few bytes of information, okay, that they contain inside. It's like an envelope that encompass the data. So you just read the header field will do. So you sample on this. Next, we move on to the ICMP, right? This is the Internet Control Message Protocol. So you can see that these are also used by the routers and the nodes, okay, or the switches, right? So all the various connectors, the nodes that you see earlier in the other chapter, that basically can predict, okay, how many hop you need, how many nodes ahead of you, and which node should I go to, or which router should I go to. So the the ICMP is the protocol that basically define, okay, how to check on some of this internet. So they verify against like whether the IP address is correct or not. Not that you give an IP address like 999.9999.999, right? So that is an invalid IP address, or IP address that does not belong to this this domain or whatever. Right? So they also look at the port number as well, right? They also verify the port number address is not something that is more than 16-bit, for example, right? So they also verify that, check on that. So, and they also look at data packet, like for example, the time to leave and also the number of hop. Remember, sometimes some of the field also define the number of ports so that you don't jump too many. So you might define that after, don't know, 90 hop or after 10 hop, this data packet will, if have not reached the destination, it will be discarded. Otherwise, the data packet will just float around forever, okay, on the data, on the internet. Next, we move on to the UDP. UDP is user datagram protocol. This is a protocol that is always used to compare against TCP, right? They always use this. The main difference between the TCP versus a UDP is actually one is connection, right, oriented, which is you need full connection, complete connection between the sender and the receiver, just like the telephone, right? You call someone, the other party must not be busy. They must be able to answer your call. And then once the connection established, then you can talk, right? So that is TCP. UDP is a connectionless, just like the email, right? So you don't have to wait for Mr. Liao to open his email. Okay, you just send your email. You can post your letter. You don't have to worry about the receiver, whether it's busy or not around or not running the application, doesn't matter. You just send, okay, and hope for the best that it will reach and route and deliver to the receiver doorstep, just like your SIM post, right? So you deliver the letter, just hope that the postman will safely deliver the message to the other end, okay? So that is a connection. So you don't require a full complete connections. Okay, so that's UDP. Okay. Next, we move on to talk about the address resolution protocol. So this is the ARP, right? ARP, address resolution. So it resolves addresses. It resolves IP addresses, for example, right? So that's why it's called address resourcing protocol, right? So it doesn't just interpret, but it's also try to do a map, okay, mapping table. So sometimes they got the translation table. So you have got this source IP address, usually the local, and then the destination, and also the source port number, and remember the service number, service ad number, destination number, and there's also this thing about the global IP address. You notice that these are like the public IP address, right? Public IP address, just like this, right? If you look at this router, actually it hides the private address, right? If you look at some of these, the routers, usually the public, like ISP, will assign you with a public IP address, right? Public IP. We call this the public IP address because this is exposed to the internet, exposed to the public, right? Whoever sent, they will only see this, right? Just like if you are in NUS, right? NUS, then the outsider will see NUS IP address as this, right? So this is a global public IP address, okay? And then the network, these are the network address translator, right? Where you translate, right? So the router will do a mapping. So it will say, map to this private IP address. So these are all private IP address, internal. We call this the internal or the private IP address. So you can see it's like a 192.168. Typically our home, right? If you look at your home Wi-Fi, you'll find that your home Wi-Fi, your computer, your smart TV, your iPad, even your handphones, if they were to connect, they will be given some of this randomly dynamic. If it's running on the DHCP, right, your routers will be able to assign randomly some valid IP address, and usually these are the internal private address or local address, right? So you can see that here we can manage. That's why you are designing what you've been designing for your assignment is basically all this internal private local IP address. So you are given the free will to use, right? You don't have to worry about this address same as outside, so they reserve it. So in a way, this NAT, right, router also protect the internal addressing, okay, from the public. The public, like I said, they will only see this public IP address, which is 109.1.155.209.167, right? So they will only see this. They want to send anything, they go to this this part, and then they will map it to according to the address internal private. So all these addresses are protected, so they are hidden. They are hidden behind this NAT, which means that if the hacker want to hack into this particular important server, for example, this could be the server that contain all the exam paper and the exam answer sheet, or it could be your customer data, or it could be your NRIC health data or transaction data, credit card number, whatever, right? So the hacker will be more keen to attack this server instead of this or this, right? So they will have to try to find out what is the IP address. So if you are hidden, then they also got the task to try to find from this mapping to be able to locate the server. So it's another level of difficulties. So you might not be able to attack, right? Any hacker from the outside will not be able to attack, okay, the internal PC easily, because all these PCs, you have to try to find out what is the IP address that is supposed to map to this machine, right? Because all these private address or local address is being hidden by these NAT routers. Okay, and because of this practice, that also allowed IP version 4 to exist until now, right? Because we find that even though we have a lot of devices connected to internet, we actually can reuse some of the local IP address. Okay, because every institute, every company, the internet service provider only need to allocate them with 1 or 2 or a couple of public IP address, right? Not that if the company got 500 workstation or computer, right? Then the ISP will have to give 500 over kind of an IP address. No need. They might just give them 1 or 2 public IP address. Then it's up to this NAT router to map accordingly, right? So this is the NAT translation table, right? So this is where it will map. Okay, so they will map based on the address resolution protocol, right? So you have this address resolution protocol which will map like IP address to the MAC address, the physical address, right? So this is the soft address. This is like a hard address, cannot change one because I already mentioned these are being etched into the chip itself by the manufacturer, right? So it's very unique. So this is MAC address. Usually you can't alter using software, right? These are the one that you can configure and you can change, right? Then you have also got the translation table, right? So this is like a translation table. So translation will map like, oh, this source MAC address is supposed to go to this destination IP address and what port and what port. So the NAT, the routers will basically, or the server will keep track of all the mapping table. This will go to which global IP address as well, right? Take for example, right? If you're still lost, right? Example like this particular map over here, diagram. So for example, if somebody from outside send, okay, like this IP address from this guy, he send to the internet and the internet route to the public IP address, which is this 23. Let's say I want to send to this company, right? The company's public IP address is this, so it's 23 ... something. Then include some numbers, and this will basically map to the relevant IP address, which is the local internal IP address, right? So they use this number 11. Like for example, 11 will map to actually this internal IP address, this .12. And then if it's a 05, you'll map to the 10, right? And this will map to this. So it's just like if you stay in a house, maybe 01 is the daddy, 02 is the mommy, 03 is the eldest sister, right? Example. So you can map it accordingly. So they have this software, okay, they can memory that basically store some of this mapping table. They call this the mapping table, so that they can map. Okay, even because when it comes in, it uses public IP address. So how do I know this public address is assigned to which particular internal IP address, right? So they do that. So once you let's say like in this case, I'm sending it to actually something 11, right? So you will know that, okay, it goes into this, right? So you map it from the translation paper, you're supposed to map to this IP address, which is the .12. So you will go to .12, right? So .12 will maybe reply back and then you will also put in, okay, the assigned number, okay, which is the assigned number, so that when it receives, so that this guy will know it's supposed to be this number 11. That's why they will know. Okay, so that's one way where this address resolutions protocol worked out. Okay, so it's used to transverse. Let me just see. So the destination address might have the IP address, but the IP address is not the exact internal IP address. So you can only address to the public, right? So the message, data message that finally derived to the NAT server, then it will be able to map it to according to the fixed IP or internal IP address, and also map to the MAC PC, MAC physical MAC layer. The IP address will contain the network, right? That's where you use the masking, okay, to tell which part. Your IP address will contain the network ID as well as the server, the host ID. Okay, so that is also part of the, it's a completeness. So this part will contain the network ID and the host ID, right? Okay, that form the whole internal private IP address, right? So your private IP address or your local IP address, all this source IP will contain the network ID as well as the host ID, right? We learned that in the last chapter, isn't it? It's two that combine, and then they use the masking to tell people how long is the what's the range, or how long is the network ID, okay, whether it's 256 bit. Okay, or the complete one or what. Okay, so you have basically the last chapter we talk about that, right? So it will constitute two. Okay, next we move on to DHCP, right? DHCP is a dynamic host, right, configuration protocol. This is where you don't assign a fixed IP address. So far, your assignment is more like roughly a range, right? And sometimes you fix the diagram that show you. Students usually put in the fixed IP address. Okay, there's pro and con for about having a fixed IP address. It may be a bit more secure, right? But it's a bit more tedious, right? Whereas in the DHCP, it's more dynamically assigned by the DHCP server. So you need a DHCP server to assign, right? So when do you use this? It's usually in public places, like maybe the school lab, okay, maybe in the shopping mall, right? If you go to shopping mall, you go to McDonald's, or you go to Coffee Bean, StarHub. Sometimes they offer what free Wi-Fi access, okay, free Wi-Fi access. So the moment you enter your password or the Wi-Fi password, right, you didn't set any IP, right? So it's actually the Coffee Bean or the StarHub, all these public places, they will just assign you randomly with a IP that is free, that is a range. So they work out a range, just like what you did for your assignment one. You also need to work out the first IP and the last IP, and then that's the range. And then dynamically you will assign when there's an IP that's available and free, right? So this is the job of a DHCP, where you don't have to enter fixed IP address, or you don't have the IP. Otherwise, the public will have to enter an IP address, right? So this DHCP will randomly and assign you with a dynamic IP address, which means that every time, let's say you hook up to Wi-Fi, to Coffee Bean or Starbucks, okay, you're given an IP address. Tomorrow you go back to the same Coffee Bean or Starbucks, you'll be assigned another IP address, right? So it's actually seamless to you, transparent to you. Just like when you go back to the universities, right, campus, you go there, you go to the Wi-Fi, okay, you basically hook up. Immediately you can find that you are being assigned an IP address, right? So the school actually assign you with an IP. So it take away the cumbersome for you to set your own IP address, and they'll just give you one random IP address, right? So they also use this to control the number of access. Sometimes you go to a shopping mall, right? When you want to use their Wi-Fi, then suddenly not enough IP address. They will tell you, oh, all the valid IP address has been assigned, so you don't have you can't surf the internet, right? So you still need a valid IP address before you can use the Wi-Fi services, right? Because you don't have a fixed IP address, you don't have an IP address, messages can't reach you, right? So people can control, right? So for example, a shopping mall, they have a maybe they only allocate about 500 kind of IP address, right? Then if all the 500 people come in and use up, then you got to wait for somebody to log off, to came up from the Wi-Fi before they assign. So it will basically assign you. Sorry. So all devices will need an IP address, right? Without IP address, how to connect to the internet? You can't. Why? Just like every house got an address, right? If you got no address, then how people address you, right? How does the message, how does the letter reach you? So you need an IP address. Similar for your home, right? At home, right? Most of our home are all using DHCP. They just randomly assign to you, or some of you will configure yourself, right? So, but you need a valid IP address before you can surf the internet. Without an IP address, you can't surf the internet. Right, so at the server side, this is a server desktop. You can actually set, click on the DHCP server so that it can assign you with the IP address. Okay, so so this is how you can also add a domain, okay, to your computer. So for example, you log in as a, this is just a video demo. So this is every time you can actually set a domain, okay, right? So we can go ahead and set a domain. Let's say you are HR department. That's where your assignment are doing, right? You can set your own network, intranet, so you can give it a domain, right? Whether you are a student or you are staff, so they can control. So this is where you can define your own domain. Of course, you need the admin right, huh? So you got to have the admin right to basically get you to go in. Okay, so you can see that that's been changed. Let's see, just take a look. But in case you still don't know how to set up the IP address, this is where you can set up your IP address. Go to the internet. Okay, under the properties, right, you can see the IP address that's been set. Then you can just go to your TCP and change. So I think in your lab exercise wise, I think more or less you have gone through this, right? So remember, this is where you can actually set your IP addressing. right? IP, but this is more of a fixed IP address. So you just see, and then the subnet masking. Okay, this is to tell you that the first 255 bit is actually being used, reserved. Okay, so which means that this is actually being reserved for the network ID. The rest is basically the host IP address, right? So you need to get that. And if you know your DNS server, domain name system, right? Server, right? Later on we'll talk about this. This is also a translator, so you can tell where is my domain name server, right? Or DHCP server. So you must tell them so that they know where to do all those translations or network addressing, etc. Right? So this is a fixed IP address. So you can see that these are fixed, right? So once you perform this, you're basically doing a fixed IP address. Unless you use a DHCP, then you choose this, obtain IP address automatically, right? So you will need a DHCP to assign you with an IP address, a valid IP address. But if you perform like use the IP, means you're doing a fixed IP addressing, right? So you fix it, right? It cannot change. So this is where it allows you to point to the DNS server. This is on PowerShell scripting now. This you also did it before. You use the command prompt, right? But if you learn a little bit more, which is not covered in today's chapter, I mean this module, there's actually a PowerShell script that you can write. Right. The other thing, of course, you must make sure that you also enable. Okay, your DHCP server need to be enabled, right? Before you can do, right? So if it's not enabled, then you will not be able to assign your a valid IP address. So you also need to point to the valid DHCP server. Right, so I think this is the domain name. This is nothing there. Okay, this is where I teach a bit on the operating system. Right, so the address is assigned by DHCP server. Right, so your server, you need to set it up, right, and you will temporarily assign an IP address. And some of these, okay, the client, the dynamic IP address also got timing, right? It can expire, right? Maybe every hour you need to renew the IP address. So this is also about securities, right? Right, back to the NAT, which is something that we've talked about, right? It's basically the NAT, the router basically have got the entire local area network to the internet, right? So they basically translate all the local area network to the internet. Okay, so it's something like just now I mentioned, all these are the local IP address and it's able to map to a public IP address, right? So this is a security features. Why they use such method is to hide all the workstation, the IP address, right? So the hacker cannot do a specific workstation kind of attack, right? They will have to find out where are the workstation, what are the valid IP address before they can launch a denials, a DOS attack or denial of service attack, right? So your attack have to be more precise, otherwise you're attacking the wrong workstation. So that is part of the reason why we want to use this. And of course, the other reason I also mentioned, right? So with this kind of a network addressing translation technique, you actually allow more IP address, more unique IP address, right? So you can reuse. So these IP address are generally being reused. For example, this network ID 192.168. I think 1 or something. These are very popular. Right? If you go to your own home Wi-Fi router behind, right, it's always start with 192.168.1. Right? So you have, I have, everybody have. So these are reusable. So with this kind of reusability technique, you find that IP version 4 still can be used, right? We don't have to rely on IP version 6, right? That's why you don't see a lot of IP version 6 still implementing. Maybe when 5G come online, maybe you will see this IP version 6 will have to be in place. Okay, so yeah, so here already highlighted. Okay, the world cannot see the local area network. Okay, this is also good, right? Just like you also don't want everybody see how your house, internal house look like, or who are in your house, right? So you also don't want. So I can give you my postal code, right? So all you can get is right down to my building, right, below, but you do not know which unit, you do not know who is in your house, and you do not know the name of the person in the house. So that's what it means, right? We can actually hide some of the private informations. So these are usually used for private IP address, right? 172.192. These are some common reserved IP address that is actually being used, right? So the range is roughly here. So you can see that some office environment, or if you go back to the university campus, they might be using this quite often. Most of the lab PC are 172 dot something something something, whereas home user, okay, where at home usually is 192 something for public. So there's some reservation, but these are block of for private use, which means for local area network, not for the public addressing. Means you will not be finding this IP address in some of the public IP, right? Means IP address that is exposed to the internet, right? Like this, right? These are exposed. They are so exposed to the internet, right? Everybody can ping, right? You know, we can ping, right? You remember the second lab or the first lab? We did the pinging, right? We ping the Google, right? We ping the Yahoo, and this is what we get. Okay, this is the public actually. They return you back the public IP address, but you do not know what's inside Google, right? The Google inside have their company. They got so many workstation, work server, file server, database server, right? Web server. All those things are behind the firewall, behind their public. You only see their front door, which is this public IP address, which is also like the Singapore postal code, right? But you do not know what are the IP address they use, or which station is being assigned with which IP address, right? So if you use a DHCP, the more you have to look at the NAT, right, to find out exactly if I were to attack this database server, right? Hey, which internal IP address should I get it? And then if I try another day, the DHCP might assign another one. So that even more difficult to hack. Right, so that's where again we have got this network address table. So how do we know, right? Once you reach the public IP address, but how do you know, okay, that the public IP address is for who? It's still too big enough, right? So many information messages is being routed to, let's say, NTU, right, to the IP address. But NTU got so many other schools, school of IT, school of health science, school of SIDM or whatever. So there are so many other, right? So how do you know which station it goes to? That's where the NAT translator table will already got a mapping table like this, so that they can assign accordingly to the valid local IP address, right? So so basically the NAT will translate, it will replace, okay, the message packet, the header, they will switch, right? So the NAT, like I say, is like a memory space. It contains all the relevant mapping, and you'll be able to switch the address back, right? So like, for example, if somebody send this, right, .11, so it's meant for this. When this IP address .12 send out, you will be able to map it. When it goes out, it will basically goes out as this, okay, as the source IP address. So the IP address, which is the source IP address, will be changed, will be swapped. Okay, the source IP initially is this address, but later on you've been swapped by this. So the public will only see this plus the .11. So this is .11 will basically be assigned to this, right? So who assigned this is just like the security guard or whatever administrator, they will map this. So this is done by the program, by the router, by the NAT server, whatever, okay? Move on is the virtual private network, right? So these are typically used in a secure environment and it's being implemented by most office, right? Most office, because most office, they have their own intra network, right? They have their own intra application, they have their own security, they have their own important informations, right? Especially the pricing list of their product, especially their customer information. You also don't want your competitors to know who are your customer data, and also your HR, your human resources informations, right? So there are also a lot of confidential, company confidential informations or sensitive. So you need to ensure, especially now, there's a lot of remote access where you work from home, and you have to remote tunnel into the company's office network, right? So that's where you require a virtual private network, right? So it's meant to be a secure connection by riding on the internet, okay? By having a tunnel, just like a tunnel, you go inside the tunnel, then nobody can see what's inside, right? So that's why it's like the tunneling protocol, right? So it's kind of like encrypted, right? So unless you got the decryption key or the key to basically do the decryption, then you can read the messages, right? You can still see the messages, but it's all scrambled, right? It's all scrambled, so it's all encrypted. Right? So World Wide Web, as we know, is all just an immersed kind of collections of all the web pages, all the resources are there, the cloud, all this. That's why you call cloud, because nobody know how the network inside will look like, right? And it doesn't know how it's been routed, right? Unless you do a trace route, right? So that you can route back, you can do a reverse engineer, but these are all routing informations, right? So web pages are usually in the form of HTML, right? So, and the protocol that basically carry these HTML pages or web pages are basically the HTTP, Hypertext Transport Protocol, right? So these are usually dedicated to transfer those browser information, web pages, right? So I'm sure you heard about URL, right? URL are basically like this, the addresses, right? So you find that the addresses itself has a few important parts. The first one is about the service type, the kind of service type. So in this case, it's a HTTP, right? So it's a browser, or it could be a file transport protocol where you are just transferring file. Last time you used to have a lot of file server, right? Where you can actually download some file repository or some of the R&D work or some of the designer work. Okay, so some engineers, they work as a team, then they collaborate. So they have a dedicated file server where you can download and upload. You can check in your document. You can check out your documents to do amendments, etc. Okay, so that is a service type. Then you follow by the // then you have got the domain name, right? The domain name, which is usually the company name or whatever, right? So organization name. So you have a domain or the host name. Sometimes the host name is referred to the machine name. Usually it refers to the server name, right? Server computer name, for example, because the server are usually the one that hosts, okay, all these resources, right? All the web pages, all the application, all the files, etc. So usually, so you have the HTTP followed by the domain name. That domain name sometimes is being segregated by whether it's a company or it's an education institute, and then followed by maybe the country code. Like if it's .sg, like sometimes you put in www.yahoo.com.sg, right? So you have the moment you have a .sg Singapore, then they'll look for Yahoo server in Singapore, right? So maybe you think it's faster, and there's also some localization that you have done, right? But by default, if you never put in a country code, you'll be routed to US, right? So US is the one who invent all this, I suppose, right? That's why their default, right? If you never put, it's basically .us, right? So if you want to go China, then it's .cn, right? Then followed by the web pages or the file name, right? So that's where you put in like example.htm. So it will be likely be a file that is inside this folder, okay? And you have inside this server, and you are basically retrieving this HTML file, right? Or it could be a program, Java, or it could be ASP or Java, JSP, Java server page, right? Or some ActiveX server page or whatever, right? So basically reading, or you could be writing your web pages in PHP, right? Then you will try to retrieve from there. Unless it's also retrieving some executable file, then you put exe. So you have a file name, and usually you have also got extension. Right, so here you have a domain name. Just now we saw the domain name system, right? So the domain is basically just give it a group or department name, something like a categorizing, right? So you have a DNS server. Just now you also saw, I show you, you also, if you know your DNS server, even server also need IP address. Anything that you hook up on the internet need some addresses. So you need an IP address. So even for DNS, file server, web server, they all have a dedicated, usually is a fixed IP address. So you need to tell, okay, even your intranet or the various workstations, where is the DNS server, right? If you never put in the DNS server, then how will the DNS server be able to identify it's you, right? So the DNS server basically also do translation. One of the work is basically to translate. Like I say, I believe you have pinged Yahoo or Google, right? Can you still remember the IP address that you ping? No, right? Most people don't remember the IP address. Very difficult to remember numeric term, right? So what is more important is basically we human, we can only understand word string easier, like Google, Yahoo, Facebook, or want to go to any other places, we basically put in, we punch in not the IP address. So how does the word, the string like google.com being translated to IP address? This is all taken care by the DNS, right? This is all taken by. That's why we are being spared the effort of remembering the IP address, right? We just remember www.sim.com or edu.com, right? Or uow.com, right? So we just remember the domain name, the whole machine name. It's so easy to remember, right? Compared to remembering the IP address, right? And also the good thing is when you type in this google.com, they will be able to, because this Google server, like I say, Google or Yahoo server, there are so many users. You can't depend on just one server. You might have a number of server, okay, that is using this machine name called google.com or domain name.com, right? To be able to serve the different millions of users all over the world, right? So that's why I mentioned you might have a Google server in Singapore, another Google server in Indonesia, Philippines, a number of places. So it depends. So each of these server might be able to serve their local populations, right? And who assign the IP address? Well, it's the DNS server, right? So the DNS server will basically translate, right? Just like your name and admin number, right? Then I can't remember all your admin number. I might be able to remember some of your students' name, right? But I also need a mapping table. So this DNS server also the same. It has a mapping table to be able to map, okay, map to your admin number, right? Joseph, who this is your admin number. So you have got that table, and these are the DNS server that basically contain all this translation. And you can do forward DNS, okay, where you try to ping and then you return the public IP address, right? Public IP address is public, something public. You can ask, you can request. So the DNS is the one that's going to tell you what is the actual IP address. So in fact, you can also surf and browse the internet, okay, using IP address, right? If you know this IP address, you can actually type http://216.58.211 if you remember, so you can type this also can. That's even easier than this translation, right? So this is but you have to remember this. Okay, so you can do a forward DNS, it will return the IP address. But if you want to put the IP address, it can also return you the string, the domain name. So internet, there is a wide variety of services, right? You can have email, you can do Telnet, you can do MSN messaging, you can voice over IP kind of a video streaming, right? You can do audio streaming, you can do instant messaging, you can do tweet, you can do blog. There's so many services that is actually available on the internet, right? So that's why you need the port number to differentiate some of this. Right, especially for email, right? Email itself, they also have their own protocol, right? They also, every messaging have their own fixed kind of a standard kind of a handshaking, some kind of a protocol that you need to establish. Otherwise, you will not be able to understand. So for email, they basically use SMTP, right? Simple Mail Transport Protocol. They use SMTP to basically transmit email. And beyond that, they also got other messaging format like the MIME, right? This is a multi-purpose internet mail extension, right? It's basically used to handle attachment, right? Attachment. We always attach a lot of things other than writing the body text subtitle. We also attach pictures, PowerPoint, Word document. So who handle that kind of a messaging format or attachment? So this is handled by this multi-purpose internet mail extension, right? So email, you can do sending, you can receive, you can store in the draft, you can reply to, you can forward to. So there are many, and some even can attach with different multimedia, right? Audio files, etc. So, and they also have other, for the post office, they also have their own protocol versions that you have to buy, including the IMAP, okay, Internet Message Access Protocol, right? So I think for this module, you don't have to look into too technical, but at least you must know some of this naming, right? Like at least you must know SMTP is for mail server, right? For mailing, for email, right? And HTTP is for browsing, and FTP is for what? Right, and but ASP is for what or what, right? Or FTP, right? So you got to know some of file. So FTP is basically for file transport protocol, right? Where you transfer file across the internet. So you can actually upload file, you can download file. So these are handled by the FTP, right? And you can also do this via the browser, right? So via the browser is instead of HTTP, you use the FTP, right? So, but nowadays we can actually do transparently using HTTP to download files also. Right? Then Telnet. Telnet is more to handle remote access, okay, where you are not near the office or where you're outside the office, right? So these are quite commonly used nowadays, especially a lot of people are working from home, or sometimes the network administrator, the network engineer, they can actually remote tunneling into the server, the actual server machine, to do fine-tuning, to do updating, to do patches without actually go into the server room, right? So this is where it allows the remote locking, okay, into the system, right? So where you don't have to be physically inside the server, right, to do it. Then we have got the voice over IP. So that will be transferring of audio, the video streaming. Okay, so now you can see that internet also is capable to transmit audio and pictures files, right? So they also use packet switch network, right? Remember, we mentioned about packet switch. Packet switch is for most of the internet that transmit out, right? You have different size, different parcel, right? But you got to chop them into a standard packet, right? So this is why it's called packet switch, right? Because for all the different size of multimedia files or text that you send out, okay, they're all split into standard packets, just like a container ship, right? You want to send something, you manufacture something, you want to deliver to another country, you basically have to fit into a standard parcel, standard container, and fixed size, and you, of course, you try to fill it up as much as possible, right? And each of these packets might be routed through different paths, right? It don't have a fixed path, so it depends on the router settings or the traffic conditions of the internet, right? So the internet will have, go through a lot of nodes, a lot of routers, a lot of switches. They will switch your data packet in different paths. And that's why all these data packet, when I ship it out, let's say I got 10 container, I have 10 data connect packet, it will be routed through different paths, and you'll be sure that some of the data packet will reach early, right? Some will reach late. That's why you need also the sequence number, so that you can, you know which one comes first, which one second, then you can join back. The receiver will have the task to be able to read the sequence number of the packet, so that they can put them in order before they can read it in the right sequence. So now, very popular, you need all this. Sorry, let's start some question. Okay, why do some companies have their own private email server? Right, like I say, it's all depend. Right, it depends on you, depend on the company. Why do they want to have their own server? Easy to manage. Right, they don't want to be at the mercy of, let's say, Yahoo. Let's say a company can always use Yahoo or Google. Why they still have their own? Just like SIM, why do they have their own SMTP server? Because why? Because every batches, every year got new students, they have to enroll them, they have to manage all these things, right? They got to take them out, right? And sometimes, okay, confidential email they want to keep within themselves, especially in the school environment. What is most confidential? The exam paper, the exam answer, the student results, okay, and the students enrollment or whatever, or so there is a lot of things, right? And also maybe the universities, they have their own research paper, they have their own thesis, those students taking their masters, and they want to ensure that these are well controlled and contained, right? So you can have your own mail server because you want to have the control, right? You want to manage it, right? If you subcontract out this mail server to Google, to Yahoo, to other cloud server or other company, then you might be at the mercy of them, right? Like I say, they might, who knows, they might sell some of your stuff. Okay, might not be the company's fault. Like I say, there's always some bad people, okay, in the company, right? That maybe because they're not given the right reward, okay, they're being fired. The day before they fired, they took out some document, they can steal some data, right? After all this, there will still be somebody in the company, like a network database administrator, the network engineer. They will have access to some of this privileged information, right? A lot of hacking actually takes place because of insiders, because of people who resign or people who already know the network setup. They know how to attack. They know what's the IP address. They know the user ID and password. They know which part can access, which one is cannot access. And some companies, they even come up with their own honeypot kind of a setup, right? Where they attract hackers to go in, and that could be fake information, right? Honeypot is like maybe the school, right? They can set up another fake network and contain all the bluff student ID, bluff result, fake result, okay? Not the real students' results, etc. Right? And then that they put it as a honeypot to attract all the hackers to attack that. Right? Either it's easy to access, easier to attack, and they can use that to monitor. So when your new one is not being being attacked. Right? Just like if somebody very rich, they got a real safe, then they also got a fake safe. Right? They try to hide it even better in the real safe where it contain all the money or the treasure, and then they come up with maybe put in a little bit of money there that they can afford to lose. So there are ways of doing this, right? Network. So it depends on the company. So it's up to you. Of course, if you got the extra money and you got because when you host your own resources like email, your web server, your file server, there's also some hassle, right? Some maintenance required. You have whoever maintain it must make sure that the server is 24/7. You must make sure that the service patch are always updated. The antivirus must be updated with the latest dictionary, right? And you also have to monitor every day. Got any people, any funny intrusion? You might even have to install intrusion detection system, right? Or you might need to have a UPS, uninterrupted power supply, right? That power can actually run out, right? Electricity might run out, right? So it's possible, right? Last time used to happen a lot of electricity not enough, not just like recently China, but such a big countries, they also they have power shortage, right? They have power shortage. So what does it mean? Power shortage means your server cannot run, means your system is down, then you're dead, right? So of course, if you can get a UPS, right, or generator to generate your own electricity, then you're safe, right? So it's all about controlling whether having your own server is important or not. Then we have all these instant messages, okay, that allow us to do Microsoft. Nowadays don't have Microsoft messages. They have also other messages, but nowadays we use more of WhatsApp and other means. But before Instagram, before before Telegram, before Twitter, we used to use MSN messages, right, or the IM messages, right, through the computers. Just like Twitter, right? Twitter nowadays quite a lot of people use that, right? Maximum, they have their different target, right? So Twitter is good for short messages, right? Donald Trump, when he was the US president, he loved it. He loved it. That's the best. Okay, but now what happened? His own favorite social media kicked him out. Okay, after he, I don't know, badmouth them, right? And they don't like him, or when he was not even the most powerful person in the world, and got kicked out from Twitter, right? And then now Donald Trump has to form his own social media company, right? Recently, I think it's a True Social, right? So he's coming out with his own True social media, not easy, company, so that he can manage the messaging. Is one of the best ways that he can reach out to his followers. He got millions of followers, right? And Twitter actually surprisingly kick him out of the tweet, and even Facebook also kicking out, right? So a lot of social media actually kick him out, and I think he was also saying that it's just not fair, right? When he not the terrorist, where there are some terrorists still have Twitter account, and he being the US president, ex-president, he don't even have, right? So so there was one time that the government, the country, start to scrutinize the power of social media company, right? They start to question that Facebook, Instagram, Twitter, okay, all these YouTube, social media, how would they have the power to say no or yes to some account, right? Terminate some account, right? So it's like, well, they're getting having too much of a control, right? In terms of the what news to be broadcast and what news to be not broadcast, right? So that the government are very concerned, right? Because it's like the government couldn't control the social media informations, right? So information is very important, right? Especially in wartime, right? When you are in war, a lot of things depends on what information. Where is the danger zone? Where is not the danger zone, right? So if you can cut off the internet, cut off the information, the whole countries could go into a blackout, right? Nobody knows what happened. So you go back to like 50 years ago, right? When we don't have an internet, okay? When we don't have an internet. So what can you do? Depend on the news, right? So like when I was young, right? There's no internet, there's no handphone, there's no WhatsApp, right? I managed to live my life through without internet. I'm not too sure you guys can live 1 week without internet. Right? You will be so bored. You will be just like information shut down. Right? You don't know what's happening. So now is information super highway, where information travels so fast, instantaneously, and can reach out to the whole public citizen, right? So yeah, just like some of you went through confinement, right? But you still got the internet. You can still surf the internet, right? So this kind of a lockdown, like now, all this circuit breaker will not be possible without all these people well connected. And look, if you look at now, every time got some news, immediately everybody knows about it very fast. Last time got any new things, any new policy, well, you got to wait for next day newspaper to come out to read. That's about how information travel right now, right? So internet is a superpower highway information. So there's a lot of services, and it's expanding, it's growing in terms of the e-retailing industry, in terms of data interchange, data transmissions, right? So all of us are well connected, and all of us are well informed. Okay, that's also very important, right? Well informed. We are always very well informed. We are constantly looking at the handphone most of the time, right? I bet that every 1 hour you look at the handphone at least once, okay? Unless you are busy with something, right? So we are all pretty well connected in one way or another. So there are some things like cookies, okay? I'm not too sure we went through this before, but cookies is like data, short, small data that's captured by the web server, so that they can enhance your web browser experience, right? So these cookies are kept, okay, on your machine, on the client, okay, because a lot of things cannot all store at the web server. Then people will say, well, intrusion of privacy lah. You know exactly where I've been browsing and all these things, which is true, right? So they can actually store some information at the client machines as a cookies, as a cache memory, so that the next time you visit this website or you visit these web pages, I know you have been browsing. It's not the first time you browse my web pages. It's not the first time that you've been looking at a camera, or it's not the first time you have been looking at a few of the SLR camera. So they can basically capture some of the customer browsing habits by storing small data called cookies in the client machines, right? So that kind of eliminate the intrusion of privacy. I say all your state information, all your browser information is actually stored at the client end, but the server can actually retrieve it. But I didn't store at the server end, right? So at least I'm safe, right? In a way. So they basically use cookies as a way to store state information, so that they know, okay, this, like I said, this is more to enhance the user subsequent visit to your website, so that they can go to, they know that you have browsed to this page, they just show you other products, other things, right? Instead of showing you again some of the repeated informations, okay? And with this cookie, it's also allow you to browse from one page to another page, because a HTTP protocol is actually a stateless protocol, but it doesn't keep track of your state. So you need to have a program to basically take note of every session that you make. So those who done programming, you know that you have to capture the session ID and then use the session ID to keep track as you browse through the various sites in the pages, right? They are able to keep track. Okay, where have you browsed from, and when, and if you go back, it maybe is able to go back to your previous state, right? Otherwise, if you don't keep track of this state, then I will not know, or you might not be able to grow back or go back to your previous page, right? Everything go back to the first page. So these are just mechanisms that's been put in place, right, to allow some saving of the customer habitual browsing, or even to enable some customizations, right? So intranet, I'm sure we know what's an intranet. It's just an internal network, right? These are network, local area network that you set up in your own company, and you only allow your own employees to access to the company's resources. So all those resources, files, program, all those things. So that's the intranet. I think all of you know. But there's also another one called the extranet. Okay, extranet. So what is this extranet? Okay, so sometimes, okay, the intranet is also extended to outside corporate and outside your own partners, basically suppliers, or it could be customers, right? So sometimes we allow, okay, our suppliers to access to our network, okay, so that they can go and see what are the in our warehouse, what other things is left, or whether our ingredients is running low, right? Or we can have an invoice internal ERP system, enterprise resource planning system, where we have a network set up with the supplier. So the moment we issue an invoice, okay, you will be alerted, right? The moment you deliver certain product, you will receive the delivery order, for example, right? So these are intranet. So basically it's built so that supplier, your close partners or your customers, okay, they can share the same network, intranet network as you, right? So that you can provide a more seamless, smooth transactions, okay, in most of the dealing, right? So this is more like B2B. You can call it the business to business. Those who study e-commerce, they will know, right? So it's more than just a B2C. B2C can be a big market, but I can tell you B2B, the business to business, that even a bigger scale, right? Where millions of dollars is being transacted through that. That is where even the bigger transactions going on. The public are buying usually just a few dollars, few cents, $10, $20, $100. But when supplier are dealing with another supplier or with your companies, right? You might be dealing with millions or hundred thousands of dollars of transactions, right? That is where this intranet is important. And then sometimes companies don't just deal with one supplier. You will need multiple suppliers, right? Like Singapore government, we very kiasu one. We always have more than one supplier. You don't depend on Malaysia to deliver eggs or chicken every day or veggie. You also buy from Indonesia, Philippines, to diversify your supplier